Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today, inshallah, we will start together in redox reactions. In our lesson today, we will know how we can solve half ionic equations for AS and A-level students. At first, we will start to memorize the meaning of redox reaction. Number 2, we will start to know the steps of calculation and for solving the redox equations. At last, we will start to answer some questions from now. Try these questions in your chemistry book. Let's start together. At first, we will start with the definition of redox reactions. Redox reaction is a type of chemical reaction consists of two main parts, reduction and oxidation. The first part is oxidation. Oxidation is gaining oxygen. Oxidation is losing hydrogen. So it is the meaning of oxidation, at first gaining oxygen or losing hydrogen. We studied it before. Oil rig. Oil means oxidation is losing of electrons. So in the case of our reaction, we have element X. The electrons will transfer from element X to element Y. So we can say that element X is oxidized by element Y. Element S loses electrons. So element X is a reducing agent. Element X can lose electrons. Element X increase in its oxidation state. For example, we can write 0, 1, 2, 3, 4. And down we can write -1, -2, -3, and so. So in the case of oxidation, element will lose electrons. By losing electrons, the element oxidation state will transfer upwards. So we can say we have increase in the oxidation number. We have increase in our oxidation state of the element. But in the case of reduction, reduction is losing oxygen. Reduction is gaining hydrogen. We can say reduction is rig. Reduction is gaining of electrons. Element Y is reduced by element X. Element Y gains electrons from element X. Element Y is an oxidizing agent. It is gaining electrons. Element Y, we have decrease in its oxidation number. It means that in the case of reduction, we will have decrease in the oxidation number. The element will gain electrons. Electron charge is negative. So we will have decrease in the oxidation number. So we know what is the meaning of redox reactions. Now we will start together in the steps of solving the redox reaction equations. At first, we must calculate the oxidation number or the charge of atom, molecule, or ion. So we must find the oxidation number of our element. We must calculate our element or atom or molecule or ion charge and identify if we have increase or decrease in the oxidation number. If we have oxidation losing electrons or reduction gaining electrons. We must know principles for calculation the oxidation state of our elements, especially for transition elements. Because in the case of transition elements, we have variable oxidation state. Let's start at the first step the oxidation number of gases in its elementary state, like nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine gas. The oxidation state of all gases in its elementary state is 0. It is the first principle. Number 2, oxidation number of elements in its elementary state, like for example magnesium, like for example sodium, chlorine as element, and aluminium, and so its oxidation state is 0. So if we have element in its elementary state, we can say its oxidation state is 0. Number 3, oxidation state of hydrogen is usually +1, except in the case of metal hydrides, except in the case of sodium hydride and calcium hydride. Why except in the case of sodium hydride and calcium hydride? Because metals has a large ability to lose electrons. Because metals can lose electrons easily. So in the case of metal hydride, like sodium hydride or calcium hydride, the metal like sodium or calcium will lose its electrons and the hydrogen will gain electrons, and it is not preferred for hydrogen to gain electrons. So in this case we will have hydrogen, its oxidation state is -1, not +1. So in the case of metal hydrides we have different case. Number 3, the oxidation number of oxygen O is -2, except in the case of Na2O2 and hydrogen peroxide. Hydrogen peroxide H2O2, we are talking about compound. Oxidation state of oxygen is not -2. Oxidation state of oxygen is -1. Because we have 2 hydrogen atoms attached to 2 oxygen atoms, so the oxidation state of oxygen will be different. So it is only 2 cases for the change in oxidation state of oxygen. Oxidation number of fluorine is -1. Oxidation number of group 1 alkali metals is +1. Oxidation number of group 2 alkaline earth metals is +2. Oxidation state of neutral compounds like sodium chloride, for example. If I have sodium chloride, its total oxidation state is 0. It means the sum of oxidation state of its elements equal to 0. For example, we have sodium. Sodium oxidation state is +1 because we have an element from group 1 alkali metals, plus chlorine Cl, it is halogen. Oxidation state of chlorine is -1. So we can say that the total oxidation state of sodium chloride is 0. The same in the case of magnesium chloride MgCl2. We have magnesium atom attached to 2 chlorine atoms. Oxidation state of magnesium Mg is +2. Oxidation state of chlorine we can calculate it from the reaction as the total oxidation state equal to 0. So we have 2 chlorine atoms attached to magnesium atoms, so we have Cl2 plus 2 equal 0. So we can say that Cl2 equal -2. So only one Cl atom will equal to -1. So it is the oxidation state of chlorine atom in the case of magnesium chloride. Oxidation state of charged compounds equal the oxidation state of the charge. So the total oxidation state of MnO4 is -1. So we can say the oxidation state of magnesium plus oxidation state of 4 oxygen atoms equal -1. So we can calculate oxidation state of magnesium as magnesium is transition element Mn plus 4 times oxidation state of oxygen is -2 equal -1. So the oxidation state of magnesium Mn plus -8 equal -1. So Mn equal +7. We will transfer -8 on the other side with different charge. So we have +8 minus 1 equal +7. And then we want to balance any increase or decrease in the oxidation number of the element by adding number of electrons or removing number of electrons with equal number of charges. Then start to balance all the atoms by multiplying. If you have any atom is unbalanced in your equation, start to balance it by multiplying by 2, multiplying by 3 other hydrogen or oxygen. If we have excess of oxygen, start to balance the equation by adding water to the opposite side of your reaction. If you have excess of hydrogen proton, start to balance your equation by adding hydrogen to the opposite side of your equation. So we use adding hydrogen proton to balance the excess of hydrogen, and we add water for balancing excess of oxygen. So if you start to follow the following steps for balancing the redox reaction equation, it will be very easy for you to calculate and solve redox equation reactions. At first, calculate the oxidation number of the unknown element. Usually, unknown elements are transition elements. Oxidation state of group 1 alkali metals is +1. Group 2 alkaline earth metals is +2. The oxidation state of chlorine is -1. The oxidation state of the elements like gases in elementary state, like for example in the case of fluorine, oxygen, nitrogen gases, oxidation state is 0. Oxidation state of elements in their elementary state, like for example in magnesium, in potassium, in sodium, in elementary state is 0. Oxidation state of compound is the sum of oxidation state of its element. If we have neutral compounds, so the sum of oxidation state of our elements equals 0. If we have charged compounds, the sum of oxidation state equals the total charge. And if we start to balance the equation, at first we start to balance the number of electrons. We can balance the number of electrons in our equation just by adding or removing electrons equal to the number of electrons required to balance the equation. Then to balance the equation, if you have atoms unbalanced number, start to balance the number by using multiplying. If we have excess of oxygen, balance it by adding water to the opposite side. If we have excess of hydrogen, start to balance it by adding hydrogen proton to the opposite side. So let's start with the first example in our questions. Question number 1 from Try This Question. Produce a half equations for the following changes. At first, the oxidation of chromium CrOH by 3 to CrO4-2 in an alkaline solution. First step, start to calculate the oxidation number of chromium in your compound. We have CrOH by 3 equal 0. We have neutral compound. On the other side, we have CrO4 equal -2. At first, we want to calculate the oxidation state of the transition element chromium. We have Cr plus. Oxidation state of hydroxide group is -1. -1 times 3 equal 0. Cr -1 times 3 equal -3 equal 0. So Cr equal +3. On the other part, we have CrO4 equal minus 2. Cr plus 4 times minus 2 equal minus 2 because CrO4 is a charged compound. Cr equal 4 times minus 2 equal minus 8. If we want to transfer minus 8 to the other side, it will be plus 8. Plus 8 minus 2 equal plus 6. So we have chrome with oxidation state plus 3 converted into Cr plus 6. So we can say in our equation we have increase in the oxidation state. As we have increase in the oxidation state, so we have oxidation reaction. We have reaction involving losing of electrons. How many electrons? We want to balance the number of electrons. We transferred from plus 3 up to plus 6. So we lose 3 electrons. So the first step, we must balance the number of electrons. So we just add minus 3 electrons. It will form CrO4 minus 2. Now we want to check the number of our atoms. Chromium atoms are equal. Oxygen atom not equal. We have excess of hydrogen and we have oxygen. We have excess of oxygen on the other part. In our equation, our reaction in an alkaline solution. Just I will tell you the trick. At first we have CrO4 minus 2 equal to the number of oxygen atom and equal number of water molecules. If I have 4 oxygen atoms, add 4 water molecules. 6 oxygen atoms, add 6 water molecules. By adding 4 water molecules, we can say we have 8 hydrogen atoms and 4 times 1 equals 4 oxygen atoms plus 4, we have 8 oxygen atoms. So we can say we have 8 OH. We can say we have 8 hydroxide group. As we have 8 hydroxide group, we want to balance the number of hydroxide group on the other side, on the reactants. In our reactants, we have 3 OH negative. So we still need to add 5 OH negative. So we can start to recalculate the number of oxygen and hydrogen and chromium. Chromium 1, chromium 1. We have 5 oxygen plus 3 equal 8 oxygen. We have 8 oxygen. We have 3 hydrogen plus 5 hydrogen. We have 8 hydrogen. On the other side, we have also 8 hydrogen. So we have balanced equation to the number of atoms. Number of atoms are exactly equal. We want to be sure from the total number of charges. To know the total number of charges, we have minus 3 electrons. So we remove 3 electrons and we add 5 hydroxide ions. So we have 5 negative and we start to remove, we start to add to the other side plus 3 electrons. So we can say we have minus 5 plus 3 charges. Minus 5 plus 3 equal minus 2. On the other side, we have minus 2. So we have equal charges. So we can say our equation is completely balanced. We can say we wrote balanced redox reaction or balanced half ionic equation. Now we will transfer to question number 2, the reduction of VO2 plus to V plus 2 in an acidic solution. Step 1, we want to calculate the oxidation number for the transition element. We have VO2 plus, total oxidation state is 0, but we have a charged compound. So we can say VO2 equal to plus 1. V plus 2 oxygen atoms, V plus 2 times minus 2 equal plus 1. We will transfer minus 4 to the other side with plus 4, so we have V equal to minus 5 oxidation state. On the other side, we have V plus 2 equal 0. As we have a charged transition element, so we can say the oxidation state of V is plus 2. So we have an element transferred in its oxidation number from plus 5 to plus 2. As we have transfer in the oxidation state, we have decrease in the oxidation state. Decrease in oxidation state means we have reduction reaction. So we will start to add 3 electrons plus 3 electrons to our element. So we can start to write the equation. We can say we have VO2 plus 3 electrons will form V plus 2. Write the same equation, but we still have excess of oxygen atom in one part. As our reaction in acid solution, so we can neutralize the excess of oxygen atom or equal the excess of oxygen atom by adding hydrogen proton. So we will start to add 4 hydrogen protons, will react with 2 oxygen atoms to form 2 water molecules. So if we want to recalculate the number of atoms in our equation, we have 1 vanadium atom and finished with 1 vanadium atom. We have 2 oxygen atoms and we finished with 2 oxygen atoms. We have 4 hydrogen atoms and finished with 4 hydrogen atoms. To balance the charges in our equation, at first we have VO2 plus, so we have plus 1. Plus 3 electrons, so we have 3 negative charges. Plus 4 hydrogen protons, so we have plus 4 positive charges. So we can say we have plus 5 minus 3, we have plus 2. We have plus 2 charges. On the other side, we have plus 2 plus 0, so the total charge is plus 2. So we have balanced equation in charge and number of atoms. We can transfer to the next question. Question number 3, the oxidation of H2C2O4 to form carbon dioxide in acidic solution. H2C2O4 equals 0. We want to calculate the oxidation number of carbon. We have 2 hydrogen atoms plus 1 times 2 plus 2 carbon atoms plus 4 times minus 2 equals 0. So we have C2 plus 2 minus 8. Plus 2 minus 8 equal minus 6. So we have C2 equal plus 6. So we have C only equal plus 3. Just we divide by 2. On the other side, we have carbon dioxide CO2 equal 0. We have carbon atom plus 2 oxygen atoms times the oxidation state of oxygen is minus 2 equal 0. Carbon plus 4, we transferred minus 4 to the other side. So we have C plus 4. On the total equation, H2C2O4 will form CO2. At first, we have a change in the oxidation number from plus 3 to plus 4. So we have increase in the oxidation state by 1 electron. So as we have increase in the oxidation number, we have oxidation reaction. We can say that our element lose one electron. So each carbon atom will lose one electron. So at first we must know that we have two carbon atoms. So we will lose two electrons. And we have two carbon atoms, one carbon atom. So at first we want to balance number of carbon atoms in the equation. Multiply by 2, so we have 2CO2. We can say we have H2C2O4 minus 2 electrons will form 2CO2. But we want to balance the number of hydrogen atoms. We have two hydrogen atoms, just we will add two hydrogen protons as our reaction in an acidic solution. It is the balance of our reaction, and at last we will balance the total charge of reaction minus 2 electrons, so we have plus 2 charges. On the other side, carbon dioxide is 0, plus 2 times plus 1, we have plus 2 charges. It is the answer of our third question. Number 4. The reduction of Cr2O7 minus 2 to Cr plus 3 to an acidic solution. Cr2O7 minus 2 equals 0. As we have a charged compound, Cr2O7 equals minus 2. We have two chromium atoms, Cr2 plus minus 2 times 7. We have 7 oxygen atoms with oxidation state minus 2 equal minus 2. So we have Cr2 minus 14 will transfer it to the other side with plus 14. So we have plus 14 minus 2, we have plus 12. Plus 12 divided by 2, we have plus 6 is the oxidation state of one chromium atom. On the other side, Cr plus 3 equals 0. Cr equal plus 3. Cr equal plus 3, so we want to know the change in the oxidation state. We have a change in oxidation state from plus 6 up to plus 3. So we have decrease in the oxidation number. So we have reduction reaction. So we have gaining electrons. Each chromium atom will gain 3 electrons. As each chromium atom will gain 3 electrons, so we can write the equation Cr2O7 minus 2 will convert it into Cr plus 3. At first we have two chromium atoms, so we want to balance chromium atom by multiplying by 2. Each chromium atom will accept 3 electrons, so 3 times 2 equals 6 electrons. So we have Cr2O7 minus 2 plus 6 electrons will form 2 Cr plus 3. But we still have excess of oxygen. We can balance excess of oxygen by adding hydrogen protons. We have 7 oxygen atoms. So we want to convert it into water molecule. So we will add 14 hydrogen protons. By adding 14 hydrogen protons, we will form 7 water molecules. Now we want to check our number of atoms. We have Cr2, we have 2 Cr. We have oxygen 7, we have 7 oxygen. We have 14 hydrogen protons, we have 7 times 2, we have 14 hydrogen protons. We want to balance the total charge. Total charge of our compound is minus 2. Minus 2 plus 6 electrons, so we have minus 6 electrons. Minus 6 plus 14 positive charge, so we have minus 8 plus 14, we have plus 6. We have plus 6 charges. On the other side, we have 2 times plus 3, so we have plus 6 total charge. And the total charge of water molecule is 0. Now we can transfer to the next question, question number 5, the reduction of IO3 negative to I2 in an acidic solution. At first, the first part, IO3 negative equals 0. IO3 equal negative 1. We have I plus 3 oxygen atoms, 3 times minus 2 equal minus 1. We will transfer minus 6 by plus 6 minus 1. We have plus 5 charge. So we have iodine, its oxidation state is plus 5. On the other side, we have elementary, or we have iodine in its elementary state, I2 equals 0. I equal 0. So we have iodine will transfer from its oxidation state plus 5 up to 0. So we have decrease in oxidation state. Decrease in oxidation state is reduction reaction. So we will gain electrons. We will start to gain 5 electrons for each atom. Each atom of iodine will gain 5 electrons. So we can write IO3 minus plus 5 electrons will transfer to I2. 5 electrons for one atom. So we want to balance number of atoms. Add or multiply by 2 to balance number of iodine atoms. Then multiply number of electrons in 2 because we have 2 iodine atoms plus 10 electrons. Will form I2. Our reaction in acidic medium and we have excess of oxygen. We have 2 times 3, so we have 6 oxygen atoms. To balance 6 oxygen atoms, we need to add 12 hydrogen protons. So we have 2 IO3 negative plus 10 electrons plus 12 hydrogen protons will form iodine I2 plus 6 water molecules. If we want to check the balance of our atoms, we start with 2I finished with I2. We start with 2 times 3 equals 6. We finished with 6 oxygen atoms. We start with 12 hydrogen protons and finished with 6 times 2 equals 12 hydrogen atoms. To balance our total charge, 2 times minus 1 equal minus 2. Minus 2 plus 10 electrons plus 10 negative charges. Minus 12. So we can say we have minus 2 minus 10. We have minus 12. No, sorry, it is plus 12. So we have minus 2 minus 10 minus 12 plus 12 equal 0. On the other side, we have I2 0. Water is also 0. So our total oxidation state is 0 in reactants and products. Next question, question number 6, the reduction of oxygen in an alkaline solution. O2 is converted into OH negative. O2 in elementary state, so the oxidation state of oxygen is 0. Oxidation state of one oxygen atom is 0. On the other side, we have hydroxide group OH. Its oxidation state is minus 1. Oxidation state of oxygen as hydrogen atom is plus 1, so oxygen oxidation state is minus 1 equal minus 2. On our equation, we have O2 transferred into OH. So we need to balance the oxygen atoms, so multiply by 2. We have change in oxidation state from 0 up to minus 2. So we have decrease in the oxidation state. Our oxidation state decreased by 2. So we have reduction reaction. So we can say O2 minus 2 electrons for each atoms times 2. So we start to add 4 electrons. Plus water for balancing the equation, for balancing the number of hydrogen atoms. So we want to check the number of atoms. We have 2 oxygen and 2 oxygen. We have 4 oxygen. 2 plus 2. So we have 4 oxygen. We have 2 times 2, so we have 4 hydrogen. We have 4 hydrogen. And we have total charge 0 minus 4 plus 0 equal 4 hydroxide ion minus 4. So the total charge of the equation is balanced. Take care, it is 4, not 2. Sorry for it. Okay, next question. The reduction of H2O2 to water in an acidic solution. H2O2, we want to calculate the oxidation state of oxygen. We have hydrogen oxidation states plus 1 times 2. We have plus 2 plus O2. So we will transfer to the other side with minus 2. Oxidation state of oxygen as 2 atoms is minus 2. Oxidation state of 1 atom is minus 1. We have oxygen atom with minus 1 oxidation state. On the other side, we have water molecule H2O, 2 hydrogen atoms, 2 times plus 1 plus O equal 0. We have oxygen atom transferred 2 to the other side with minus 2. So the oxidation state of oxygen is minus 2. So we have oxygen transferred in oxidation state from minus 1 to minus 2. So we have decrease in the oxidation state. So we have reduction reaction. So we start to gain electrons. Each oxygen atom will gain 1 electron. H2O2 plus 1 electron will form H2O. At first balance number of electrons, each one atom will accept 1 electron. We have 2 oxygen atoms, so we will add 2 electrons. To balance number of oxygen atom, we will multiply by 2. So we have H2O2 plus 2 electrons will convert it into 2H2O. We have H2O2 plus 2 electrons. We want to balance number of hydrogen atoms. We have 4 hydrogen atoms, and on the other side we have 2 hydrogen atoms. Our reaction is in acidic medium, so we will start to add plus 2 hydrogen protons. We will have 2 water molecules. Last question for today, the oxidation of H2O2 to oxygen in an alkaline solution. H2O2 total oxidation state is 0. We just repeat it. 2 times plus 1 equal plus 2 plus O2 equals 0. O2 equal minus 2. 1 oxygen atom equal minus 1. It is the oxidation state of oxygen. O2 equals 0, so the oxidation state of 1 atom is 0. We have an element transfer in oxidation state from minus 1 to 0. So we have increase in oxidation state, we have oxidation, we have losing electrons. Each one atom will lose 1 electron. In our reaction, H2O2 minus 1 electron will form O2. So at first balance number of electrons, as we have 2 atoms, multiply by 2. And on the other side, we have O2, we have O2. Okay. We have 2 hydrogen atoms and we don't have any hydrogen atoms. We want to balance the excess of oxygen atoms. We want to balance oxygen atoms. Our reaction in an alkaline solution, so we will add hydroxide ion. H2O2 minus 2 electrons plus 2 hydroxide ions will form O2 plus 2 H2O. Just check the balance for your equation. H2O2, 2 times minus 1 equal minus 2. On the other side, we have 2 electrons, so we have 2 negative charges. So we have equal charges, we have equal number of electrons. So we have finished how we can balance half ionic equation in redox reaction. I hope that you understand our lesson today. In the next lesson, inshallah, we will complete how we can balance the completely ionic equation. Please don't forget to give us like and share with your friends to get more information. Don't forget to make subscribe to our channel. Thanks very much. See you later. Assalamu alaikum warahmatullahi wabarakatuh.